In the last lesson, we learned how to immutably add to our private donuts data structure by creating out a create method on our class, and then we updated our donuts with the new payload object. We then spread in any existing donuts, i.e. our application state or our service state, because we can break things down into separate components, and then we logged out the result. So what we're going to do in this lesson is hook up the ability to edit an existing item, because we do not have this. So the easiest way to do this would be to jump into our donut form component. Now at the bottom, we have our create button, we have our reset button. Now alongside of our reset and our create, we're also going to have update. So I'm going to duplicate our create button and we're going to change this over to update. Now this leaves us with a problem because we now have a button type of submit twice. So how do we differentiate? Let's save this out and have a look. Let's say we are editing an existing item. How do we know whether we are creating or updating? Now instead of handling things on the form itself, it might be wise for us now to handle our logic in line on each particular button, because we're going to be dealing with separate events in our form. So this means completely eradicating our handle submit, and instead we're then going to bind it to a click event on the button itself. What we can do first is bind this to our create. We can then say click equals, and we have this handle submit. However, we're not dealing with a submit, we're handling something a bit more specific now. So we're going to change this over to handle create and then pass in that particular form. So if we scroll down into our component body, we then have our handle submit. So instead of submit, we're going to call this handle create, which then means we're going to have a handle update. So let's go and bind this first. I'm going to hide the style so we can scroll down a bit faster. Just like above, we can say click equals and then handle the update, because the text inside the button corresponds to our update. We then want to pass in our entire form object. So now we need to implement our handle update. So if we jump down underneath our handle create. Now this is actually quite nice, because when we are updating an existing item, we have all the data available to us. So it pretty much looks the same, and we only want to commit those changes if our form is valid. However, we don't want to emit a create event, we want to emit an update event so that our parent component, our container, knows exactly what is happening. Our markers touch logic we can leave as is as well. The only difference is when we're updating, we need to also supply the ID of the item that we're then updating. We could do this in the parent component. We could also do this in the child component. I quite like the idea of doing it inside this component just to make our lives a bit easier. And it also then encapsulates the behavior. So instead of a create, let's first hook up the ability to handle an update, which means that we need to also create an event emitter, which is also going to pass up a type of donut. So all we need to do is change our create over to update. That then creates a property on our component that then allows us to bind to an update event. So this is where our container component can then become a lot smarter, because it knows exactly what is coming out of the component. So now we need to implement this on update. So then we can jump down. We have on create. So we can say on update. This then gives us a donut of type donut. And inside the body of the function, we're then going to have a new method on our donut service, which is then going to be responsible of simply updating. Now to update something, all we need to do is just pass off the entire object. So this is then very nice and simple. It's a one-line piece of code. We then pass it off to the service does the job, and everything is perfect once it's done. So back in our form, we have our buttons, which at the moment are of type submit. However, we have bound those individual click handlers. So now we want to change these over to type of button so they do not force any kind of submit event. So we can save this out. We then see our inline click handlers, handle create, handle update. Down inside the body of our component, we then have our create and update event emitters and the corresponding callbacks. So handle create fires, which then this.create.emit. However, we need to then change that final thing, our update. So now that we have inside of our donut single, we bound an event listener to this update event, which is then dispatched inside of here, we also need to grab the form definition for the particular item that we are then updating, because we do not have the ID. Now, this is another reason why we are using one-way data flow. If you have a look, we are given the entire donut. We do not mutate it, which means that we can grab any values that we want. So what this means is we can grab the ID from this.donut.id. We can then spread in the rest of our form values and then finish off our object. So what this is then going to do is then emit upwards the whole form, which is then changed, and it's going to look exactly like the data structure that already exists with the ID inside of our service. So let's save this out and give it a go. We've hooked up everything inside of our form. We've got the update. We've removed the submit handler. We're going to stick to our click events on the individual buttons. And in later videos, we're going to show and hide these based on some root definitions. We've got our event emitter. That's all set up. We're then emitting that event with the ID. And the ID is important because we're then going to take that ID and then pass it off to an HTTP request to tell our backend which item we actually want to update. So this is a crucial piece of information for us to include. What this is doing here is essentially taking our form value, the new representation of our updated data, and then simply adding that ID to it, which means this is pretty much complete. So we can go down into our single component and we want to now implement our update method. So how do we do this? Inside of our donut service, we need to go down. We've got create, which means we need to add an update, which is then going to take another payload of type donut. This is a bit more complex because we need to go and then find the particular item that we want to update. So how do we do this? We can use an array map. We could map over our data and then go and simply detect the one that's changed. So for this, we're going to say this.donuts equals the result of mapping over this.donuts. So our map function gives us an individual donut, which we can type as donut. And inside the body of the function, we need to say if that donut ID equals the ID from the payload, then we know that this is the one that we need to update. So in which case, at this point, the way that we can update via a map is just returning a new item. So this essentially is then going to swap out the donut item. Otherwise, we're just going to return the initial donut. What we're essentially doing with our map is looking at our first item. We say, does the ID equal the one that's changed? No. Does this ID equal the one that's changed? No. Does this ID? Yes. We then have a match. So instead of updating the property manually, we just swap the whole object because here we've just mirrored the data structure, so we can just return that new piece of information. What we can then do is grab our console log. Underneath of this.donuts, we can save it out and go and test out our application. We need to, of course, first go back into our single. And now that this is not red, we can save things out. This then compiles our application. And I'm using Prettier to format my code on save. And this is really nice because when the lines get too long, it then bumps them down onto individual lines, which is a preference I like to take anyway. So this is super helpful. One for readability, but also I like to put the inputs at the top and outputs at the bottom, just to keep things nice and readable. So to test this out, we need to supply the ability to read one that already exists in our data structure. So let's take our sour supreme. We can go into our read one, paste it in, save it out. We then have our form definition. We can bring up our console. So at the moment, if we hit update, we see our objects getting logged out. To begin with, we can see if anything's changed. Nothing's changed. But let's say we want to amend the price to 129. We can then press update, expand our data structure. We have sour supreme, and then the price here is 129, and we do have that ID. If we look at our original data structure on the sour supreme, it's 139. So we know that this is 100% working. Now there's a small feature that I want to add quickly, and that is if we were to refresh the page, clear out our data, we can press update straight away. So it might be nice to update this button only when we have changed something. So what we can in fact do is specify disabled equals, and we're going to say I want to disable this if the form remains untouched. So when we save this out, this gets formatted because it breaches the line length, but you can see that we cannot update it. If we then jump into one of our fields, amend our price, we then have the ability to then commit that change. So this is just a nice way, again, to use those form validation properties in line, and we can then create some sensible user experience behavior based on what we want to achieve. So this has been quite an in-depth lesson. We've done quite a lot. We've looked at our data structure. We've created an update method, which then immutably updates our data structure. It returns a brand new array every single time and then reassigns that value to our this.donuts. This is then shared because we are accessing it inside of our donut service. We've created that nice wrapper where we are selecting that particular item. We're using onCreate and onUpdate, two different events. Now the difference, and I think this is very apparent at this point in time, of why we should use a container component. Like I said at the beginning of this course, a container component is a smart component. It's dealing with our service. It's then in charge of getting our data. We've talked about why we should use ng-on-init. It then binds these callbacks, which are just simply waiting for these create and update events happening inside of our donut form, our child stateless dumb component. Our donut form is simply acting as more of a pure function. It gets some data and it emits some data when we want to change things, and how it changes it is based on what the user is then editing. So I hope you enjoyed this lesson, and I think our application build is really coming along nicely. We are following so many good practices with this, and this architecture is going to set you up for a very solid future of building not only component architecture driven Angular applications, but the data and the state management behind them is well considered.